We'll start a very interesting system of our body, which is the reproductive system. Reproductive system is not essential for the survival of an individual. Just think that if I remove your reproductive system, you will still survive, right? You will not die. And we do all the time, remove the ovary, remove the uterus, right? Um, Not all the time, but often that is done. So reproductive system is not essential for individual survival, but now you think in a broader picture, if from this moment, next 150 years, no reproductive system works, then what will happen? Yeah, entire mankind will disappear, right? So in that way, if you think, it has a huge impact, right? So it is a very important system. Reproductive system is the most interesting system of our body because number one, because of reproductive system, we see the differences in male and female. That is interesting. And if you see the reproductive system in male and female, it is completely different from each other. All other systems are same, right? But reproductive system is completely different. If you see the reproductive system of other creatures, it is extremely interesting. In some creatures, reproductive system, both male and female reproductive systems are present in the same body and same, you know, uh, inside the same body, sperm and egg are produced and sperm fertilizes the egg. In some creatures, we see that part of their life they are male and then switch sex and become female. So all those interesting things are seen in reproductive system. If you read the reproductive system of other creatures, you will see so many interesting stories. Anyway, so male and female reproductive system. You know that male reproductive system's main function is production of what? Sperm, right? Production of sperm. But female reproductive system performs more functions than the male reproductive system. What female reproductive system does? Produces ovum, right? But also female reproductive system is responsible for the fertilization. Fertilization occurs in female reproductive system. Then fertilized egg grows and becomes what? Embryo, right? And embryo becomes fetus. You know that. All those things, the entire pregnancy is maintained inside the female reproductive system. In female reproductive system, two important cycles are occurring continuously. The ovarian cycle and menstrual cycle, right? So you see that female reproductive system performs a number of important functions and more functions than the male reproductive system. Male reproductive system is kind of selfish, just produces sperm, right? Female does all other things, right? That's truth. Truth is truth. Okay. So first, we'll see parts of both male and female reproductive system. Okay. Then we'll talk about the male reproductive system and then female reproductive system. So first, we'll talk about the parts. The reproductive system has two types of organs: primary reproductive organs and accessory reproductive organs. Both male and female reproductive systems have primary organs and accessory organs. Primary reproductive organs are called gonads. So gonads are primary reproductive organs. Male gonads or primary reproductive organs are testes. So male gonads are testes. Okay. Female gonads are ovaries. So male gonads are testes. There are two testes in female body, but two gonads. Male gonads are testes. There are two testes in male body and two ovaries in female body. Those are the primary reproductive organs. And secondary reproductive organs or accessory reproductive organs are ducts, glands, external genitalia, both in male and female. We have ducts, glands, and external genitalia. Now, what are the functions of primary reproductive organs or gonads? Number one is the production of sex cells. You know that male sex cells are sperm and female sex cells are eggs or ovum, right? So, production of sex cells is number one function. Number two, production of sex hormones. In male reproductive system, male sex hormone, it is testosterone, that comes from androgen. Androgen is the chemical precursor of testosterone. So from androgen, testosterone is produced. Female sex hormones are produced in female reproductive system in ovaries. Those are estrogen, progesterone. So those are the important functions of the primary reproductive organs or gonads. Now, sex cells are also called gametes. Gametes are sex cells like sperm and ovum. Male gametes are sperm, female gametes are ovum. Male gonads are testes, female gonads are ovaries. So, don't confuse between gametes and gonads. Gametes are cells, gonads are organs. Now, sex hormones. Sex hormones play some important roles. Number one, development and function of the reproductive organs. You know that spermatogenesis occurs at puberty, but before puberty, spermatogenesis does not occur. Why? Because sex hormone, male sex hormone, is released at puberty. That initiates the spermatogenesis, production of sperm. So, sex hormone controls the function of the reproductive system. Cycles, ovarian cycle, menstrual cycle, those are controlled by the female sex hormones in female body. So those are also examples of functions regulated by the sex hormones. Right? Growth and development of secondary sex characteristics. What are the secondary sex characteristics? Secondary sex characteristics are the characteristics by looking those, you can separate a male and a female externally from outside. Okay, so what are the features you have in male that is different than female? Here, facial hair, right? Distribution of hair. Also, what else? Secondary male sex characteristic. Laryngeal prominence, right? Adam's apple. The thyroid cartilage is bigger, enlarged. How about voice? Deeper, right? Voice in male. Prominence of skeletal muscles. In male, the skeletal muscles are more developed, right? Prominent. Not always, but usually. Sometimes I will say girls are a lot of muscles. Okay. What else? Baldness, right? Is male secondary sex characteristics. Broader shoulder. So all those are what? Secondary male sex characteristics given by the sex hormone. Female secondary sex characteristics are high pitch voice. Not loud, but you will hear from far. Okay? You will hear from far. Subcutaneous fats under the skin. Fat is nicely distributed. That's why you see its skin is soft. Number 3, breasts. Growth of the breast. Mammary glands. Broader hip, right? So those are female secondary sex characteristics given by the female sex hormones. Sexual behavior and drive. Those are also controlled by the sex hormone. You know that in general, if you just see the behavior of a girl and a boy, it is different. If you take 1000 boy, 1000 girl, and compare the behavior, you'll see the pattern. You'll see the difference clear, right? So not only sexual behavior, the behavior is different, and that is also controlled by the sex hormones in great extent. So those are the functions of the sex hormones. Okay, now we'll talk about the male reproductive system. The primary organs or gonads are testes, and accessory organs are external genitalia, that includes penis and scrotum. Glands. 3 types of glands are present in male reproductive system. 2 seminal vesicles, 1 prostate, and 2 bulbourethral glands. So those are the glands in the male reproductive system. Okay. Now you can ask me that why testes are primary reproductive organs and others are accessory reproductive organs. Why ovaries are primary, others are accessory? Why is that? Now you know that you can do in vitro fertilization, right? You can do fertilization outside of the body in a petri dish. You can take an egg and a sperm and fertilize, right? You can do that. That means we don't need other structures to do that, right? Like we don't need the ducts, we don't need the glands, we can do that. But you must get the ovum and the sperm from the ovary and testes. That you cannot produce, right? So those are very important, and we don't have any alternative. Okay. First, we'll talk about male genitalia. Male genitalia includes the scrotum and penis. First we'll talk about the scrotum. Scrotum is a sac of skin and superficial fascia, and it hangs outside of the abdominopelvic cavity. It contains the testis. So, why the testes are not located inside the abdominopelvic cavity? Why the testes are kept outside of the abdominopelvic cavity? The reason is inside the testis, spermatogenesis occurs. That means the production of sperm occurs, right? That's the function of the testis. And for spermatogenesis, the temperature is an important factor, and that temperature must be slightly lower than the body temperature. Make sense? So if the testes are inside in your body cavity, then the temperature will be same as your body cavity, but it needs slightly lower temperature. That's why they are kept outside of the body. How much lower temperature is needed for spermatogenesis? About 3 degrees Celsius lower than the core body temperature. Okay, that is important for spermatogenesis. Now, the function of the scrotum, number one, housing the testes. Testes are housed inside it. Number two, regulation of the temperature in the testes. Now, how the scrotum regulates the temperature? Scrotum regulates the temperature by using its muscles. There are two muscles in the scrotum. One is called the cremaster muscle, another is called dartus muscle. Cremaster muscle hangs the testis from above like this. So if this is the testis, cremaster muscle comes from above and gets attached and hang the testis in the scrotum. That is cremaster. Dartus muscle is a thin layer of muscle present in the wall of the scrotum. Okay. Now what happens, you see, if the body temperature increases, for example, you got fever, if the body temperature increases, those muscles relax. So when the cremaster muscle relaxes, the muscle fibers get longer, right? Because muscle has relaxed. So muscle will get longer. So that will move the testis downwards. Is it clear? If the muscle gets longer, it will move the testis. Testis will move down further away from the body. Number two, when the dartus muscle that forms the wall of the scrotum is relaxed, then also the scrotum gets big and testis moves more room to move downwards. Make sense? So because of the relaxation of those two muscles, the testis can move further down. That means away from the body. Make sense? And get away from the heat of the body. If outside of the body the temperature drops in cold weather, what will happen? Those muscles will contract, opposite, contract. So if the cremaster muscle contracts, it will pull the testis upwards, right? And when the wall of the scrotum, the dartus muscle contracts, it will move the testis upwards. The testis will go close to the body and get heat, right? So the temperature will be maintained. In high heat weather, male fertility declines, goes down. Okay? If somebody sits in a hot water tub every day for several hours, there's a good chance of having male infertility. Spermatogenesis may stop. Okay, here you see the scrotum and penis, that means external genitalia. First, we'll see the scrotum. If you see inside the scrotum, you have the testes. One and another is here. Now, the wall of the scrotum has skin, then dartos muscle, and superficial fascia. So those are the structures in the wall: skin, dartos muscle, and superficial fascia. Then you see the muscle that hangs the testis inside the scrotum from above, that is the cremaster muscle. Okay, cremaster muscle. If you see the cremaster muscle, actually it is located inside the spermatic cord. So first you have to remove the outer covering of the spermatic cord to see the cremaster muscle. Then if you remove the cremaster muscle fibers, you will see other structures inside the spermatic cord. What are the other structures? You will see in the right side. The cremaster muscle has been removed. So inside the spermatic cord, you have other structures, blood vessels, nerves, and a tube that is called the ductus deferens or vas deferens. That tube takes the sperm from the testis to the urethra. So those are the structures you will find inside the spermatic cord: cremaster muscle, then blood vessels, nerves, and ductus deferens or vas deferens. Okay. Testis. Main function of the testis is production of sperm. Sperm is produced inside the testis. If you see the outer coverings of the testis, there are two layers or two coverings: tunica albuginea and tunica vaginalis. Those are two outer coverings of the testis: tunica vaginalis and tunica albuginea. Tunica vaginalis is nothing but peritoneum that comes down from the abdominopelvic cavity. You know that in your abdominal cavity you have the peritoneum. Do you remember that? The peritoneum will go all the way down to inside the scrotum and will cover the testis. The outer layer is the tunica vaginalis, which is actually the peritoneum. An inner layer or covering is the tunica albuginea. Okay, that is a fibrous connective tissue. Those are two coverings. Now, if you see inside the testis, you will see many lobules. So, what are the lobules inside the testis? Just two coverings. Inside the testis, you see segments, about 250 to 300 segments inside the testis, and each segment is called a lobule. Each segment is called what? A lobule. And lobules are separated by the membranes. Those are called septum. Okay. So this is the lobule. This is one lobule, this is another, and lobules are separated by septum. And how many lobules? Each testis has 250 to 300. And in each lobule, you have 1 to 3 coiled tube-like structures. 1 to 3. It is not fixed. It could be 1 or 2 or 3. And these coiled tubules are called seminiferous tubules. So these are the coiled tubules called what? Seminiferous tubules. So in each lobule, how many you have? 1 to 3. Now, in the wall of these seminiferous tubules, spermatogenesis occurs. Production of sperm takes place in the wall of the seminiferous tubule. Now, if I just see one seminiferous tubule, the seminiferous tubule, okay, and make a cross section like this, a slice, and see this part under the microscope, what I will see, this is the wall and this is the lumen of the seminiferous tubule. And in the wall, you will see many cells. These are actually sperm. Okay? And in the outermost part, that means close to the surface of the wall, outer surface, you will see the stem cells. The stem cells are called spermatogonium. Okay? Stem cells are spermatogonium, and they are present in the outermost part of the wall of the seminiferous tubule. And the stem cells do what? Produce? Stem cells do what? What is the function of stem cells? Produce new cells, right? So they are continuously multiplying to produce new sperm. So that is the function of the stem cells here. They are sitting here and multiplying to produce new cells. And the new cells start to move towards the lumen. That means inwards. And as the new cell moves towards the lumen, that means moves inwards, it gets what? Matured, right? Gradually gets older or matured. And when the cell will come very close to the lumen, here, the shape of the cell changes. The cells become elongated. Shape changes and the cells become elongated. And this is the mature sperm, which is called spermatozoa. Okay, the mature sperm. So stem cells are called spermatogonium, and mature cell is the spermatozoa. And then what happens? The mature sperm is released into the lumen, gets detached from the wall and enters into the lumen. So now you see that the production of sperm occurs where? In the wall of the seminiferous tubule. Make sense? That is the spermatogenesis, the production of mature sperm from the stem cells, right? Okay. Now, after the mature sperm is released inside the lumen of the seminiferous tubules, they start to move outwards. First, they will pass through the straight tubule. You see, these are called straight tubules, and will enter into a network of tubules. And this network is called retitestis. Retitestis. And from the retitestis, the sperm will enter into the efferent ductules. Efferent is exit, efferent ductules, and then will enter into the head of the epididymis. You see this structure, this is the testis, and this C-shaped structure that is attached to the testis, that is called epididymis. Okay, and it has a head, body, and a tail. It's like a comma. So this is the testis, and on the testis you have the epididymis, head, body, tail. Okay, and this is testis. So first, the sperm will enter into the head part of the epididymis and will be stored there for few days. So in the head of the epididymis, the sperm is stored, and when the sperm should be ejected, it will enter into the body, then tail of the epididymis. Then from the tail, you see, it will start to move upwards like this, and will enter into a duct tubule. That is called ductus deferens or vas deferens. So from the tail, the sperm will enter into the ductus deferens or the vas deferens, and that ductus deferens, you see, enter into the spermatic cord. We have talked about that. Spermatic cord contains the blood vessels, nerves, right? Emastum muscle fibers, and ductus deferens or vas deferens. So that's how the sperm will flow. You need to remember those. Seminiferous tubules, ductus tubular rectus or rectus tubules, and retitestis, efferent ductules, head of the epididymis, body, tail, and then ductus deferens. Then ductus deferens, you see, enter into the spermatic cord, and the spermatic cord is located in the inguinal area. You know the inguinal area, and then the ductus deferens will enter into the pelvic cavity, where it will give the sperm to ejaculatory duct, and then from there it will enter into the urethra and will get out from the body. Okay. So from ductus deferens to ejaculated duct, and from ejaculated duct to the urethra. Make sense? And will get out. So that's the pathway of the sperm. Here you see the last couple of structures. Now you already know that the ductus deferens is the tube that takes the sperm from the tail of epididymis to the pelvic cavity, you see there, and then gives the sperm to the ejaculatory duct. This is the ejaculatory duct here. This is the ductus deferens. And then from the ejaculatory duct, it enters into the urethra. Now, you see here, ductus deferens is a long tube, and the last part of ductus deferens gets expanded slightly wide, and that expanded or wide part is called the ampulla of the ductus deferens. Ampulla means expanded tube. Okay, so ampulla of the ductus deferens, the last part of the ductus deferens. And beside the ampulla of ductus deferens, we have the seminal vesicle, male reproductive gland. In each side, you have one. So, seminal vesicle produces semen, and from the seminal vesicle, semen enters into the ejaculatory duct. So, you see, from ductus deferens, from the ampulla of ductus deferens, sperm enters into the ejaculatory duct, right? And from seminal vesicle, who enters? Semen. And they get mixed together, right? Semen is the fluid, and the sperm, they get together and then get out through the urethra. Okay. Now, this is the histology of the seminiferous tubule that I showed you here. If you make a slice and see under the microscope, this is the seminiferous tubule. And these are the stem cells. I told you the stem cells are present here in the outermost part, right, of the wall. And then what you will see here, the sperm at different stages of maturation, because we know that stem cells produce new sperm, right, multiply, and then they move towards the lumen inside and get matured, right? So you will see the sperm at different stages of maturation in the wall of the seminiferous tube. More mature means they are closer to the lumen. Make sense? Less mature means closer to the outer surface. So here you see some elongated sperm. That means those are the mature sperm, and will be released into the lumen here. Okay, so that is the testis and the flow of the sperm. Now we'll talk about the external genitalia organ, penis. First, we'll see the parts of the penis. It has three parts. You can write it down: root, shaft, and glans penis. So those are three parts. Root is attached to the body wall. Shaft is the body part of the penis, and end part is called the glans penis. So here you see in the left side, root, shaft or body, and the end part is the glans penis. Inside the root, you will see the tissue structures. Those structures touch the penis to the body wall. Those are called crura. Crura is plural. Crus, C-R-U-S, singular. So you have crura of the penis. Here they have shown one as crus. Okay. Now we'll see the shaft or body part. Inside the shaft or body, you have three tissue structures. How many? Three. The center around the urethra. If this is the urethra, the center around the urethra like this, you have the tissue structure that is called the corpus spongiosum. Okay, corpus spongiosum, also called corpora or corpus spongiosum, and other two structures are in both sides of the corpus corpus spongiosum, those are called corpora cavernosa. Corpora cavernosa. So one corpus spongiosum around the urethra. Again, this is the urethra. So around the urethra you have the corpus spongiosum. And in both sides of corpus spongiosum you have the corpora cavernosa. Now, inside the corpora cavernosa you have many sinuses, spaces, open spaces. Inside what? Inside the corpora cavernosa. Make sense? Many sinuses or cavities or spaces. And also inside the cavernosa you have blood vessel. Now, when blood leaves the blood vessel and enters into those sinuses in the cavernosa, what happens? The enlargement and erection of penis occurs. So, when blood leaves the blood vessel and enters into those cavities or sinuses, that will cause the enlargement and erection of the penis. And when the blood goes back into the blood vessel, then again it goes back to its previous shape, okay, condition. So now you know that for the enlargement and erection of penis, actually the mechanism is what? Accumulation of blood in the sinuses. Of what? Corpora. Sinuses of what? Corpora cavernosa. Cavernosa. Make sense? So that's how the corpora cavernosa help in the enlargement and erection of it. And that's the mechanism. You know, there are some drugs that can, keep the blood for longer time there. Will not let the blood get back. So that's how you can keep it erectile for longer time. The disease inability to erection is a problem. Okay, so you can see in the picture, if you see the bottom picture, it is more clear. That's the cross section. You see the three structures, tissue structures. Two are corpora cavernosa, and inside the corpora cavernosa you have the blood vessels and many sinuses. And around the urethra you have the corpus spongiosum. Make sense? Okay. Now we know that the ductus deferens is in the inguinal area, passes through the inguinal area inside the spermatic cord. And the ductus deferens is actually located very superficially in the inguinal area. So it is very easy to reach the ductus deferens. Just if you cut the skin, make incision on the skin, you can get the ductus deferens, spermatic cord and ductus deferens in the inguinal area. That's why, vasectomy is a simple surgery, one of the simplest surgery. Why? Because vasectomy is what? Cutting off the ductus deferens, right? So its sperm will not get out from the body. So what usually we do, this is the spermatic cord. Inside the spermatic cord, you have the ductus deferens. So we will take the ductus deferens out and then cut like this. Okay, and so after you cut, you can quarter, close by heat, or you can tie That is safe. Otherwise, if you keep them open, there is a chance they will again join, right? You know that our body uh, tissue can repair. So that's a possibility. So better safe is if you tie or protect. That is 100% safe. You know, the sperm will not get out. Okay, now um, this is a simple surgical procedure. This is called vasectomy, right? Vasectomy. You can ask the person to lie down on the table here, lie down here, and sometimes we keep the scissors and scalpel over there for the section, right? You can take them and just make incision and use the forceps to take this ductus difference out and cut it like this. That will, okay. And the person can walk out. It's not, difficult surgery. You can do that. But in female, if you want to do that, it is more complicated, right? Because the tube is inside. But in many countries, male-dominating countries, male they don't want to do that. So they tell the wives to do that. So that's a problem. Anyway, so this is the basic term. Okay, urethra. Urethra, the male urethra is much longer than the female urethra. Male urethra is 15 to 20 centimeter long. Female urethra is only 3 to 4 centimeter long. Male urethra has three parts: prostatic part, membranous part, and spongy or penile part. Prostatic part is inside the prostate. Membranous part is inside the urogenital diaphragm. The membranous part is located inside the diaphragm, that means flat muscle, that is called urogenital diaphragm. Okay, that's the membranous part. And this is the shortest part of the urethra, about 2 centimeter long. And then the last part is the longest part inside the penis, that is called the penile or spongy urethra. Now, male urethra is the passage for both the urine and the semen, the sperm. Okay? It is different than female. And in male urethra, you have three epithelial linings. You have to remember that. Three different types of epithelial lining. And you see, very first part, this is the urinary bladder. This is the bladder. And this is the first part of the urethra. Starts from the bladder. What's the lining of bladder? Transitional, all of you know that, right? So that transitional lining continues a little bit. That's why the very first part is the transitional, right? And then the most part, middle part, is the pseudostratified columnar. So first part, which part is attached to the urinary bladder, is transitional, same as bladder, and most part is the pseudostratified. Stratified columnar, and only the last part is the stratified squamous. It makes sense because you know that last part has a chance to get exposed to air or outer uh, atmosphere. So that is the stratified squamous. Chance of friction is high. stratified scopes. So those are three different types of epithelial lining in the urethra. Glands of the male reproductive system. Three types of glands are present: two seminal vesicles, one prostate, and two bulbourethral glands. Seminal vesicles produce about 70% of semen. So semen is mainly produced by the seminal vesicles, and the secretion of seminal vesicle is slightly alkaline secretion. Okay, and the prostate. The prostate secretes milky, slightly acidic fluid. So the secretion of prostate is milky secretion and slightly acidic. So when the prostatic and seminal fluid they join together, one is acidic slightly, one is slightly what? Alkaline, right? So they will mix and neutralize each other. Let's know that prostatic secretion is very important for the activation of the sperm. Although the sperm that is released into the lumen of the ductus the seminiferous tubule, that is the mature sperm, but two different things. Mature and active, those are two different things, right? The mature sperm comes out from the testis, but they are not still fully active. So you have to know the difference. Okay? They are not fully active. So partial activation, first activation occurs by the prostatic fluid, and still the sperm is not fully activated. When the sperm gets fully activated, when the sperm enters into the female body. Inside the female body, the sperm gets fully activated to fertilize the egg or ovum. Bulbourethral glands, very tiny, pea-sized glands present in the urogenital diaphragm on both sides of the membranous urethra. And the bulbourethral glands secrete thick, clear mucus, and this mucus makes the urethra slippery, the wall of the urethra slippery, and reduces the friction. And that's why when ejaculation occurs, no pain is felt because the surface is smooth and mucus is present here. That will reduce the friction, makes the surface smooth. Spermatogenesis. Spermatogenesis is the process of the production of the sperm. You know that genesis is the production, right? So the process of the sperm production is spermatogenesis. Now, you already know from where the spermatogenesis starts, from which cells? Stem cells, right? Stem cells present where? In the wall of the seminiferous tubule, right? The wall of the seminiferous tubule. The stem cells are located in the outer part or inner part of the walls? Outer, right? Then starts after the new cell is produced from the stem cell, the new cell starts to move inwards, right? Towards the lumen. Remember that? Okay. That is the spermatogenesis. So first happens, the stem cells multiply. Is it clear? To produce new cells. And that multiplication is mitosis. So first, by mitosis, stem cells multiply to produce new cells. And the then after mitosis, after new cells are produced, then those cells go through meiosis, another type of cell division. You know that there are two types of cell divisions, mitosis and meiosis. Let me first tell you the differences between the mitosis and meiosis, although you're supposed to know that from your high school, just to refresh your mind. Mitosis occurs everywhere in the body, in all cells of your body. Mitosis occurs where? In all cells of the body, all body cells. Meiosis occurs where? Only in the sex cells, gametes. Only in the sex cells. Mitosis produces two daughter cells. Mitosis produces how many daughter cells? Two. When meiosis is completed, meiosis produces four daughter cells. I have started to move. Okay, let's stop. Okay, four daughter cells. So when mitosis ends, we get two daughter cells. When meiosis ends, we get four daughter cells. Mitosis occurs in only one step. Meiosis occurs, or meiosis is completed in two steps. Meiosis 1 and meiosis 2. So meiosis is completed in two steps. Meiosis 1 and meiosis what? 2. Mitosis keeps the chromosome number same. Keeps the chromosomes same. That means 2 and 46. Okay? Diploid. Meiosis does what? Reduces the number to reduces half and 23 haploid. Make sense? Okay. So during spermatogenesis, first mitosis occurs. To do what? Mitosis occurs to increase the number, produce new cells, increase the number. That's the purpose of, main purpose of mitosis. Meiosis occurs to do what? To reduce chromosomes. What? To have. That's the main purpose of meiosis. Main purpose of mitosis is what? To increase the number. And main purpose of meiosis is to reduce the chromosomes to half. told you mitosis occurs in all the cells, right? That means also the sex cells. Meiosis occurs only in the sex cells. That means what? In the sex cells, both mitosis and meiosis occurs. That means both mitosis and meiosis occur. Now you tell me mitosis in sex cells occur to do what? To produce the new cells. Make sense? And meiosis occurs in sex cells to do what? To reduce the number of chromosomes to have. Why? Meiosis should occur only in the sex cells to reduce the number of chromosomes to half, because when fertilization occurs, you know that the sperm, male sex cell, fertilizes the egg or ovum, female sex cell, right? So if 23 comes, if meiosis doesn't occur, then the number of chromosomes will remain 46 in sperm and ovum, right? That is not good, because the new cell will then have double 46 plus 46, right? That's not normal. That's why in sex cells, first the chromosomes must be reduced to half. So now 23 will come from what? Father. 23 will come from mother, right? And N together will form 2N, 46. That's the first cell of life, right? That has 46 chromosomes. Then it will start to multiply by what? Mitosis. The body will grow by mitosis. The chromosome will remain 46 in all cells. Is it clear? Okay. So that's why the meiosis is very important, and it occurs only in the sex cells during the production of sex cells to reduce the number. Half will come from each parent. Okay? Contributed from each parent. Okay, what happens during meiosis? Meiosis 1 and meiosis 2. So this is the first cell, 46, and meiosis 1 will reduce the number to half, 23. Then meiosis 2 will form the cells, each has 23. So in meiosis 2, the number of chromosomes will not change. The number of chromosomes will reduce to half in meiosis 1. Okay, so this is more like mitosis, will remain same, and 1 will produce 2. So when both meiosis 1 and 2 will be completed from one cell, we'll get how many cells? 4. Make sense? And each has half number of chromosomes. Make sense? Okay, here you see the spermatogenesis. That means these are the stem. This is the stem cell. This is the outer surface of the wall, and this is the inner side. So stem cell, spermatogonium, you already know that, and it divides by mitosis to increase the number, and the chromosome will remain same, double, 2N. And then meiosis 1 will occur. That will, you see here, meiosis 1 will produce 2 cells, but half number of chromosomes. Then meiosis 2 will produce the new cells. So total, after meiosis 1 and 2, we'll get 4 cells with reduced number of chromosomes. And then they will change the shape, will become elongated, and will become mature sperm. This is called spermatozoa that I have mentioned before. So stem cell stage is spermatogonium, and mature stage is spermatozoa. Now in between, you see there are stages. So spermatogonium is the first, then primary spermatocyte, secondary spermatocyte, early spermatid. When you get 4 cells after meiosis 2, that stage is early spermatid. And then the cells, sperm, change the shape, become elongated, and that is called the late spermatic stage. And then the most mature stage is spermatozoa. So those are the steps of maturation. Now, if you see the spermatozoa, you see it has a head, midpiece or body, and a tail. So the mature sperm is like a baby fish. Have you seen baby fishes? Very tiny. It has a head, okay, midpiece, and a tail, like this. So inside the head, you have the nucleus. This is the head. Inside the head, you have the nucleus. And inside the nucleus, you have chromosomes and DNA. You know that, right? So that's why the head part is called the genetic region or genetic part of the sperm. Head, because it has the nucleus and nucleus contains the DNA. You know that, the genes. Genetic part of the sperm. On the head of the sperm, you have a nice cap, like the crown of Queen of England. So you have a cap on the head, and that is called acrosome. It's also called acrosomal cap. Same thing, acrosomal cap or acrosome. That acrosome contains a fluid, that is digestive fluid. So that cap contains the digestive fluid. And then if you see the meat piece, this portion is the meat piece. Inside the meat piece, you will see what? The mitochondria line up nicely, like this. All mitochondria will line up there in the meat piece, right? So mitochondria produce what? Energy. Metabolism occurs, right? You know that metabolism occurs. So this part produces ATP, and this is called metabolic region or part, and produce ATP or energy. To do what? Why you need energy here? To move the tail, move the flagella or tail. That's the last part. That's the tail part, or also called flagella, and the sperm swims, moves by beating the tail. So you need ATP, and that is the locomotion part. Locomotion is the movement, right? Locomotion region or part. So head part is the genetic part, mid piece is the metabolic part, and tail part is the locomotion part. Those are the three parts of a mature sperm. Now, why you need the digestive enzyme? Because you know that this is the egg or ovum, and the sperm gets attached to the egg, right? To fertilize it. Now, egg has thick wall. Egg has what? Thick wall. So the sperm has to do what? Dig, right? Have you seen the guys break the road, use the drill, right? So the sperm gets attached and start to drill the wall of the egg. Now, to drill or destroy the wall, the acrosomal cap releases the digestive enzyme or fluid. So that fluid will destroy the wall, so it will penetrate. And interestingly, many sperm get attached to the surface at the same time of one egg. Egg is much bigger, sperm are very small, right? Many sperm get attached to the surface, and they all start to dig. And when the first one reaches inside the cytoplasm, then others are inhibited. The chemical change will occur to inhibit them. They will stop moving. Eventually will die. It's like 100-meter race. You have like 100 people are running. Only one prize you have. So you will first try very hard, right, to reach there. But if you see somebody is far ahead and has already arrived there, then what you will do? You will get you will not die, but you will get upset, right? Oh, there's no point of running anymore. You will sit there. Don't want to use energy anymore, right? So the sperm will do the same. Will stop moving and eventually will die. Okay. The last thing, abnormal sperm. Abnormal sperm is main reason of male infertility. Main cause of male infertility. And that's why if infertility, um, we suspect male infertility, we'll check the sperm under the microscope to see two things. One is the count. The count is low or normal. That is one thing. Number two, the shape of the sperm. What we see in infertility sometimes that the sperm, many sperm got double tail, two tails. Normally that should be one, right? This is one type of abnormal sperm. Now you just think that uh, if the sperm has one tail, it can beat and move, right? Now if two tails and they move in different directions, it will stay there. It's like when you do boating, rowing. If two persons sit on the boat, and if you don't know how to do, one person hits in one direction and one person in another, your boat will not move. Right? So it will not move much. So that is one reason of male infertility. Sometimes we see double-headed sperm. So head is heavy, cannot move much. Sometimes we see the head and tail of many sperm are split, separated. They are not together. So you will see many tails, many heads, but they are separated. So those are useless, right? Sperm. They will not be able to move. Those are the abnormal